Hi, we hear the words or phrases that something is better than nothing or nothing is better than nonsense. What is right, which one is of these two is right is highly dependent on the context. But we'll try to learn something from bacteria and repair mechanisms based on what is good. Something is better than nothing or nothing is better than nonsense. Let's see. I'm Dr. BCMR, Assistant Professor at Shastra. We are going to learn about translesion DNA synthesis. And as it says, lesion is a kind of injury and trans is how to synthesize across the lesion. Here the lesion that we are talking of here as an example is thymidine dimer. Assume this is something replication is on the go and there is a thymidine dimer and photolyase has not repaired this region yet. And DNA polymerase is reading, this is the top strand is the template and the bottom one is the newly synthesized strand that is being newly synthesized. And once DNA polymerase encounters such thymidine dimers, it doesn't know what to do. It cannot add because DNA polymerase is highly specialized to add bases as accurately as possible and as fast as possible. DNA polymerase 3, that is the specialization of it. A high efficiency because replication has to be finished within as fast as possible and it should not make mistakes. So because it is specialized to be that efficient and we have these thymidine dimers, and what should DNA polymerase do when it comes to this location? It is unable to read these thymidine dimers because they have formed a cyclobutane ring, and then there is a problem because DNA polymerase is unable to read, so it won't add anything and replication is being halted. If you don't finish replication, the daughter cells will have serious trouble and they might be non-productive cells. And if the problem, that is, the question is itself is kind of existential crisis that the existence of the bacterium itself will come into question or trouble. So when such situations happen, DNA polymerase 3 will dissociate and fall off the replisome at that location. And now we have special enzymes. The enzymes called as Pol4 or Pol5, DIN-B or UMUD prime. These enzymes, their specialization is to be highly non-specific in the sense that compared to DNA polymerase 3 has high processivity because of the sliding clamp. It is highly efficient and it has a high rate of polymerization. If you take these enzymes Pol4 and Pol5, they don't have processivity, they don't have accuracy, that is fidelity of polymerization, and they don't have speed, they have almost nothing. They have the superpower. Their superpower is, if there must be, is to read through these lesions. And when they are reading, what do they add? They add anything that is available. That is, the question we started off with, is something better than nothing or nothing better than nonsense? Here, if we take in this context, that is, if replication did not move ahead, it is going to be trouble because the cells might die. The daughter cells may be incomplete and they might die. So somehow finishing the job in those conditions is what is important. So DNA polymerase 4 or 5, they would just add whatever bases are available, and because their processivity is less and they fall off. And from here on, DNA polymerase 3 can take over and will start polymerizing. So here, being non-specific or just the ability to just add some whatever is the specialization. And it is good that it doesn't have a lot of processivity because if it is processivity, it would have added many wrong bases in all the places. And that is how these enzymes are useful. And why is this important in the first place? It is something like, as long as the hope is on the way, because if we can exist, and there is always help that can come from outside, and then these mistakes, whichever are there, can be repaired, and then we can revert to what the original information, genetic information was. So if there was an opportunity at some time, because DNA information comes from outside, we can use it for repairing. We can add adenine in here in this location, or maybe photolase has made these thymidine dimers or resolved them into two independent thymidines, and because of which now we have a mismatch, and mismatch repair could remove this guanine and add an adenine in the end. So that is how all the machinery that it has, the cell, bacterium or even eukaryotes have, is to keep the mutations are continuously happening, and we somehow have to undo those mutations. And that is a fantastic way, and there are multiple ways of how these are accomplished. I hope you made your own decisions about what is good. Something is better than nothing, or nothing is better than nonsense. Thank you very much. See you later.